multiplying powers, dividing powers, but we've only dealt with positive exponents, and today we're going to cover what we do with zero and negative exponents. The first one, any number, x, 10, whatever, raised to the zero power is always 1. And you're probably wondering why that's true, and that's a rule you're going to want to remember. But the first thing is just to drive home the fact that this is true for any number. So 4 to the zero power is 1. 99.2 to the zero power is 1. It doesn't matter what the base is. Even if the base is a product, everything inside the parentheses is being raised to zero power, so it's all turning into 1. Now, there's two ways to think about it. First, you just look at the pattern. 2 to the third is 2 times 2 times 2 is 8. 2 squared is 2 times 2 is 4. And just think, to get from 8 to 4, we divide by 2. 2 to the first is just 2. And again, to get from 4 to 2, we divide by 2. So if we kept that pattern going, if we divided by 2 again, we would get 1, which is exactly what 2 to the 0 is. Another way to look at it, or to think about it, is to use the multiplication rules that we just learned. We just learned that 2 to the third times 2 to the fourth, right? We have to add those exponents, because if you think about it, you just have 2 times 2 times 2 7 times, because you have 3, then the number 4, that's 7. So you just get 2 to the 7th. Well, if we apply the same rule down here, we would get 2 to the third plus 0, which is just 2 to the third. So we had 2 to the third times something equal 2 to the third. And the only way that that makes any sense is if that something is 1, because that's the only way you'd end up with the same thing that you started with. All right, so we can apply this. The first one, only the r is being raised to 0 power. So only this is turning into 1, right? So I can think about this. I still have 4 times 1. That's all being raised to the 4th power. So I just have 4 to the 4th power, which is just 4 times 4 times 4 times 4, which is 16, 64, 256. And over here, though, the entire quantity is being raised to the 0 power, so the whole thing just becomes 1. Now, negative exponents. This is a rule that you're going to have to remember. Just like exponents in the beginning, when we learned how an exponent is just an instruction, a negative exponent is also an instruction. A to the negative n is a reciprocal of a to the n. So whenever you see a negative exponent, it's telling you that that's the same as that number 1 over that number to the positive exponent. Notice this is negative n, and that's positive n. So, for example, 3 to the negative 2 is just 1 over 3 to the second. Because remember, if you wanted to make this a fraction, you could put that over 1, and you're just flipping it. That's how you're getting the reciprocal. Okay? So, it doesn't matter where the original number is, because let's say we had 1 over 3 to the negative 2 like that. You're still flipping this. So you're still going to end up in this case with 3 squared over 1. Both are getting flipped. You're finding the reciprocal either way. So it works whether it's in the numerator to begin with or the denominator. We can see that in this example too. So in this case, 2 to the 5th is being raised to the negative 6. And remember what we learned. We could think of that as 2 to the negative 6 over 5 to the negative 6, because it's applied to everything inside. And again, that negative is telling me that has to go down there, and this negative is telling me that has to go up there, and you just end up with that 5 over 2 to the 6th power. So how can we apply this? The way I like to think about it is I'm just going to move the pieces that have negative exponents. So m to the 4th stays, 2 stays, but the m to the negative 3, that has to go down. So I'm going to rewrite it. I have m to the 4th times 2 over m to the 3rd. And again, it's positive 3. Okay? So I have 4 m's up top, 3 m's on the bottom. I can think of that. If I line them up, I have 4. 3 pairs are going to get canceled out. So all of these, I'm going to just switch colors here. All of these are getting canceled out. 3 of these are getting canceled out. So I still have 1 left. And so you're going to have 2 times m on the top, nothing, or just 1 in the denominator, which is just 2m. Over here, right, what's getting moved? Well, the y to the negative 3, that comes down. The x, remember, it's not the 2, it's just the x here that's being raised to negative 1. That's coming down, right? So I can think about it like this. I'd have 2x to the 3rd times 2 times y to the 3rd over y to the positive 3. And then I have that x that's coming down too. So now what's getting crossed out? Well, y to the third, y to the third. And then I have 1x, and I can cross out one of those and then one of them up here, and so I would be left with 2. So I'm going to be left with 2 times 2, which is 4, x squared over 1, or just 4x squared. All right, again, what do we apply it to? Remember what this is saying is the entire quantity inside the parentheses is being raised to the negative 4. So that whole thing has to come down. So it's going to be 1 over 2x squared to the 4th, which is just 1 over 2x squared times 2x squared times 2x squared times 2x squared. And that's 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's 1 over 16. X squared times x squared times x squared times x squared. I have 8 of them if I line them up. So 1 over 16, x to the 8th. Okay, this one, we have to do something before we worry about that exponent. This y to the negative 3, that has to come down. So we're going to end up with 2x to the 4th over y to the 3rd. And that whole thing is being raised to the negative 1. So now think about it. The whole thing is getting flipped. So you're going to be y to the 3rd over 2x to the 4th. And since nothing can be simplified, we're just going to leave it over there. But just again, keep in mind the order that you should do things in, right? You have to do the inner parentheses first, then you work on that exponent that's applied to the whole thing. All right, 2 more. Again, what's moving? Well, this y to the negative 3 is going up. This is going down. That's going down. Everything else stays in place, so let's just rewrite it. So we have 2x to the 4th times what's coming up, the y to the 3rd. Okay, now let's see what's on the bottom. Well, we already have our 3x squared. The z to the 4s are still down there, but the y to the 4 is coming down, and then another z to the 3 is coming down. So we can simplify that as 2x to the 4th, y to the 3rd over 3x squared, y to the 4th, but then we have 7 z's, so z7. So now, is there anything that we can cancel out? Yeah, so we have 4x's over 2x's. I can get rid of 2 pairs, so those are both gone, and I'd be left with 2 of them up in the numerator. The y's, I have 3 in the numerator, 4 in the denominator, so 3 pairs can go. So all 3 of these are gone, and I'll get rid of 3 of those, so 1 of those y's is left. No z's in the numerator, so that's staying. So let's see what we got left. We got 2x squared over 3y z to the 7th. And notice, nothing left can be simplified. That's always a good check. All right, last one. So we're going to combine what we learned about the zero exponents and the negative exponents. So the first thing I'm going to do is I'm just going to look at this y to the 0 is just 1. Z to the 0 is just 1, right? So I'm just multiplying 1 times 1. So that's just 1. That's not really doing anything, right? All right, so now next, what's moving? This y to the negative 1 is coming down. Z to the negative 1 is going down. X to the negative 4 is going up. So let's see what we got. We got 3x to the 3rd. Nothing left in the numerator if I'm just looking at the numerator, right? Okay? But the y to the 1st is going down, so we just have y. And the z is going down times z. All right, so now let's look at the denominator. The x to the 4th is actually coming up, so that's times x to the 4th. And then the y, that's just 1 times 1, so we're not going to worry about that. All right, so if we simplify that, we have 3x to the 7th, right? If I wrote them all out, I'd have 7x's over yz, and nothing there can be simplified, so you are done.